So thank you very much, everybody here, for joining our joint webinar session, Webswing and QF-Test. It's mostly a technology demo, plus a bit of background information from Webswing, and compared to the German version in the morning, I'll also say a few words about QFS, because many guests here that were invited via Webswing that may or may not know QF-Test. We're going to start with a presentation from Webswing, and then I'll do a demo showing the integration. So I'm handing over to Igor.
Thank you. Thank you very much. So I guess you can see my screen, the future of Swing. I will talk a little bit, few minutes about Webswing company, and together with my colleague Andre, he will talk you through a little bit the basics of the technology, what technologies are used, how it's used, and how is the what is the architecture of Webswing itself. So let me start. This is where are we based. We have two offices. We're both in Europe. One is in Dublin, other one is in Bratislava. So we work from Europe, European time. And our customers are mainly for North America, Western Europe, Far East. We have significant customers from China as well, and as well as from other countries. Webswing is not a big company. We are up to 15 people. We are very focused on the technology. It's actually our only revenue stream. So what we do is Webswing licensing. So our two revenue streams are Webswing licensing and Webswing custom development, and we do not do anything else. So this is only what we do. So we are, company is called Webswing Limited. The product is called Webswing. We are doing Webswing. This is all what we do. So much about us. What is Webswing? It's a technology or a web server which allows you to run any Java Swing application inside your web browser exclusively using HTML5. It can not only be Swing, but it can be also JavaFX application, Applet or NetBeans, and it can run in any browser effectively while using only HTML5. So much about the technology, what it does. And how does it work? I want to ask Andre, if you can please tell us a few words about this.
All right, so Java Swing uses Java AWT toolkit for the rendering. The Java itself comes with 3 different implementations based on the operating system and the distribution that you have basically installed. One is for Windows, another is for X11, that's for Linux, and the third one is Mac. So these 3 implementations are out of the box available for the rendering purposes. On the next page, please, Igor. So yes. Webswing provides a 4th implementation that is a web-based implementation. So we are basically using this Java AWT toolkit events, rendering events, and we are intercepting them and sending, instead of desktop, we are sending them to browser, to HTML5 canvas. So there we have a bit of JavaScript on the HTML5 canvas for rendering these events, and basically we have a mapping of all Java rendering events to HTML5 canvas events, and also vice versa, user events captured by a browser and sent to the application back through the Webswing. That's all from the overview point of view. Just a little bit know that there is usually there is no need to change anything in the Swing application. Sometimes there are some little changes required, but usually it doesn't require to change the source code of the application. If there are any questions to this or to other features that are provided by Webswing, we are here. You can set up a call with us and we will go into detail there. Otherwise, I will give word to Greg and the test tool.
Yep. Thank you, Andre. Here are our contacts. So if you have any further questions, please feel free to contact us on sales webswing.org or support webswing.org or via our contact page on the web page. Thank you very much, everybody. So much about WebSwing.
Thank you very much, Igor and Andre. One question: how long have you been around? When did you start?
Well, the technology started sometime in 2012, actually, as a hobby project by our founder, Victor, and the company itself was established 2015 as the limited liability.
Thank you. So that for context. So I'll start sharing my screen now. I'm not very good with slides, so I just have some graphics here. And I also wanted to say a few words before we start with the technical demo about QFS and QF-Test. So let's use this QF-Test, our product, for the guests here joining from Webswing. We've actually been around for 20 years now. I started in 1999 with the first proof of concept for testing Swing applications. And the company was founded in 2001, and we have grown slowly but steadily to around 20 people now. And we are, in many respects, we are similar to Webswing. We are also one product company, highly technology oriented, extremely focused, and we have survived for a very long time now. And besides Swing, we added engines every few years. You can also test JavaFX and Eclipse SWT. Around 2008, 2009, we added the web browser technologies, and only a year or two ago, we also added support for testing native Windows applications, and the next technology is going to be Android, hopefully. No, it's really close. We are very close to the public beta. And yeah, our focus is test automation via the user interface. And we are coming from Swing. It was the first technology. We have a lot of experience there. And mid this year, one of our major customers asked us to take a closer look at Webswing, because that was what they were moving their application to, or had been moving for a while, and they needed more test capabilities. They've been testing the application with QF-Test for quite a while. And that's when we started to look into this. And it has been very interesting. It's been a pleasure to work on this, to work together with Webswing, because the technology is really excellent, and the AWT toolkit they've implemented. And the whole thing that came from it is also very interesting from a technological point of view. So for the presentation, when you have a Webswing server, you have a browser that connects via HTTP to that server. That server starts a Swing application as a sub-process. And as Andre explained, the mouse and key events coming from the browser are forwarded to the Swing application, and the graphics rendered by the application are passed to the browser. So when you are confronted with QF-Test to test Webswing, the natural idea is you start a browser from QF-Test, and you interact with that browser to open the Swing application, and you do everything through the browser. Sounds natural. I'm starting a local Webswing server here, and create a quick setup sequence for a web application with QF-Test. Server runs at localhost 8080. I just want to use WebDriver mode, which is better to use the Chrome debugging tools. Okay. So we start the browser from QF-Test. Takes a few seconds. So in this setup, we have a single client, the web client. I can record the login. Can select the demo application. We have added our world famous car configurator here to Webswing. We actually didn't have to change a line of code in the source. It works out of the box. So this is the recording for logging into the application and clicking the image and waiting for it to load. And now I can also record interactions here. Sorry, we did add the German version here, but only for the demo. I hope that's okay. And we get a recording. We can replay the recording, but for people who are experienced with QF-Test, if you look at this, you see mouse clicks and you see coordinates. And here you see target components, which is always localhost 8080 canvas. And it's all the same. And when I close this extra window here, you see it's always the whole window. And if we look at it, the Chrome development tools, we have a different shortcut here in the English version. No. We also see what Andre already explained and what was to be expected. We have a single canvas component here with which to interact, and creating a test based on that, all just using coordinates for a complex application, is not going to work in the long run. It's just looking at those colored pictures with no real information what's behind it. It's not going to work. So we dropped this approach. Let me also close this browser here and close that web server. Make sure it's really stopped. Okay. Because what we really need to work with a Swing application is to connect to the Swing application and not just to the browser. And how can we do it? Well, for QF-Test, the natural thing is to start the application itself. It passes on information via the environment, attaches a Java agent to the target application. So all we need here is to start the Webswing server locally. And then when that server starts a sub-process, the environment is going to get forwarded and we'll be able to set up the connection. So our latest QF-Test version 5.2 comes with a very comprehensive demo suite with a lot of explanations about how everything works and with dependencies that take care of starting up things. So I'll start the Webswing server from QF-Test now. And for your information, it's also possible to run the Webswing server on a remote machine and still connect to the applications from QF-Test, but it takes a lot more setup. It has certain network requirements. It has significant performance overhead. We can set it up if you're interested in this. It's highly individual. The recommended way, if possible at all, is to start it locally. So we should have a server running here. And I used to have a Chrome browser somewhere. So let me connect to the application. So the application has come up and we're seeing here, client has connected for engine AWT 0. And when we look here, we now have a why is that called localhost 80? That's interesting. We have the Webswing server. It's the client variable from the previous call. Doesn't matter. We have the Webswing server and we have the Swing client application connected. And I can do recording now through the browser. And I can record checks as well to verify the elements on the user interface. And they already see that we have detailed information available. And this recording looks very different. No coordinates, target components are actual Swing components. We have the table here and an element in the table. The text input, the result check. And I can replay this as well, and it just works. So, great stuff. We can do Swing testing in the Webswing browser, but we need to interact with the browser as well. It's just half a step. Next step is we will need to control two clients simultaneously and make a combined approach. So let's reset here. And just takes a few seconds for the browser to shut down. Shut down. So this time we use the demo suite we are provided with just a minor change to go to the car config demo instead of the swing set demo. It's starting up again, and this time it takes care of all three parts. It has started the Webswing server. We're starting the browser from QF-Test. We're logging in, selecting the application to start. It's all done, fully automated, waiting for the Swing client to connect. Now, after a clean reset, we have the setup that we want. We have the Webswing server, we have the web client here, the browser, and we have the Swing client, the application running inside the Webswing server. And the good thing, if you're already a QF-Test customer and you have perhaps a significant investment into the tests you have created for your Swing application, the good news is that basically the tests will continue to run out of the box. And to prove that, let me just reset the dependencies, though the two suites don't conflict. What I have here is our standard car config demo from the demo suites provided with QF-Test. It's just one single change. I'm not going to override the client variable because the client now comes from the other setup. It's the Swing client. But apart from that, the whole test suite will fail to run because it's a German version. No, it might just run. No, it won't. I'm sorry, this is one of the things I did not set up cleanly when preparing for this demo. I'll use the German version of the demo suite instead. German version. Client variable disabled, dependencies reset. Run the otherwise unchanged demo. Proof of concept. So the application is unchanged, the tests are unchanged except for a single node, and the whole test runs out of the box, same as it would when running on the desktop. Which is great stuff. Proves that the toolkit implemented by Webswing is really done very well. So the Swing application really feels at home, even when driven from QF-Test, which is not trivial. So this covers, start one more time, this time with a different demo. This covers a lot, but not everything. It does not cover the end-to-end situation from the end user's point of view. Because so far this has proven that the Swing application runs well when treated by QF-Test as a normal Swing application, just running in a different virtual environment, in the Webswing environment instead of on the desktop. All the events are simulated. So in this isolated box, it is okay. But we have not verified yet that the interactions done through the browser work in the same way. And we have not verified yet that what is presented in the browser really reflects what there should be, what the user is expecting to see. So we need one more thing, which is some way to join the whole thing. Our first idea was, okay, we will talk with the Swing application, and then instead of replaying the events there, we will determine the geometry of the target components, take this back to QF-Test, talk to the browser, let it perform a click, back to QF-Test, interact with the Swing application. Sorry, we have some background noise here. Is anybody not muted? Everyone appears muted. Strange. So the first idea was to have kind of QF-Test playing the messenger between the two applications. And one point, spark of intuition, we had a different idea. And this idea turned out to be beautifully elegant and very easy to implement thanks to Java RMI system. Because what we can do is, with the two clients open, we can also establish a connection directly between the two. And in fact, this is the whole script that does the joining. There's a bit more behind the scenes. Yeah, we weren't done in a few minutes of scripting. But this is the key point here. So what the script does is take the Swing playback of the QF-Test Swing engine and the web playback, and it hands the web player to the Swing player as what we call a foreign playback. So the Swing player here knows it has another engine that it can forward events to. And so for QF-Test, for the driving part from the suite, there is nothing that needs to be changed except setting a few options. And then the Swing player will do everything it does as usual. except when it comes to the point actually replaying a mouse event or a key event, that it forwards to the browser. What it does before is things like synchronization. Is the application really ready? Finding the target component, where should the click really go? Making sure the target component is visible. We're going to see why that is important. Things like that. Everything QF-Test can do with Swing. And then the final part is forwarded to web. And to set this up, let me just record a few clicks here. Maybe some here and maybe one down below. And what QF-Test has when it comes to replaying mouse events, normally events are replayed just simulated, injected into the AW event queue. As an alternative, QF-Test can replay hard events, which means moving the mouse across the desktop. Now, when we do this here, you're not seeing my mouse move, which is because the desktop in this case is not the Windows desk case, it's the virtual desktop here in the Webswing server. But now come the options. We can tell our Swing engine how to replay hard events. The default is to keep everything within Swing, which is the same setup as you have when working on the desktop, and which we suggest to use for 80–90% of your tests if you already have implemented large implemented test base, which has the same quality as when running on the desktop, same reliability. And to take a few happy paths and run those with different option settings for doing the real end-to-end test. And one of those options is to use hard mouse events. When using hard mouse events, to replay them as hard events on the web browser, which is also good for illustrative purposes, because now you should see my mouse cursor move onto the browser and click the target components there. Yeah? And you see the first click here, it goes on fonts, which is up here. And the second one on HTML elements, and the third one on button, which is now not visible, which is down here. Yeah? And always before forwarding the event from the Swing client to the browser, the Swing engine makes sure that the target really is visible. So I can replay all those three without taking care of scrolling. Yeah? It scrolls the one visible, now it scrolls the bottom one visible, and it just works. Default events should be kept as soft events. There's very rarely a need for using hard events, but you definitely need them for doing drag and drop, which also works. The main part of the testing is done using soft mouse events, and there's another option here for how to replay the soft events. And where we have soft and hard for Swing, we have soft and hard for web. We also have one more, which we call semi-hard, which is neither just simulated event on the JavaScript DOM nodes, nor does it move the mouse cursor across the screen. Semi-hard is very useful for web as it simulates a mouse event message by the operating system on the browser window here. And then the browser handles it same way as it does when user clicks. So when using semi-hard here, what you get is very fast replay again. Once you turn off the hard events here, go back to soft events, which is the default, as I said. You get the quick replay like before. You don't really see a difference, but it really is the case, and it can be proved with low-level logging, that the events are really going through the browser. Yeah, so this is really end-to-end testing, with one end being the front end the browser from the event coming, the other end being the Swing application, which takes us to almost the full cycle, with one thing still missing, which is verifying the representation on the screen. And to do so, QF-Test can use image checks. And I'm recording now an image check here on this component with the text on it. Here, okay, this was a text check. I really have to record an image check. That's better. Which may look a bit surprising here when you compare the font here and there, which is a bit of an old style way we are taking images from Swing. There's going to be alternatives in the future, but for now, the off-screen rendering that we tell Swing to do, so draw its own image of the component into a memory buffer, then hand it over. It does not do any anti-aliasing, so rendered fonts are looking quite blocky. But it's actually useful to show here the difference from another option that we have, because this is the default way. Yeah, paint your image to an off-screen buffer, hand it over. It will all look fine for icons and everything. It's just subtle details in curve rendering and font rendering that's different. But we want to verify what the user sees, so we want to take the image instead from the browser. And there's another option here: replace Swing image check as a web check. And so when we replay this check now, take a look at the browser window. It's coming to the front for doing the image check, and we get a mismatch. And when we look at the run log about the checks we had, we'll see the expected window was the clunky non-anti-aliased Swing off-screen image, but what we got was a screenshot of the same region. We can overlay the two. You see the difference here of the same region from the web browser. So for this kind of testing, using image checks can be extremely useful. You can also create an image check on the whole page, the whole window, if you can reach it. No, it's normally we don't do image checks on Windows. Takes a bit of tuning, but it can be done. So you can verify the display here, and for subtle differences between the browsers in the rendering, we also have image check algorithms where you can test not only for pixel by pixel identity, but you can accommodate for subtle differences in sizing and do a similarity check and define the probability of the match probability that you want for that. Right. This brings us full cycle here for the whole thing. The final here is also adding the client names here, as we said, starting the server, have a Swing client, have a web client, have the two interact. And the interaction even goes so far that when there are subtle differences between your normal Swing desktop application and the Swing application running inside Webswing, for example, you may need to add a user interface for saving or reading from the local file system, which is different in this kind of setup because it's running on a remote server. You may need to integrate a bit of web interaction with the main part of the Swing interaction. And with this two client setup, even that is handled well. The Swing demo, Swing set demo here has a HTML component which is also technically very, very cute. A web component laid over the canvas that renders the swing part. So you can really integrate those two neatly. Also very well done by Webswing. And when you record these, you see here we have the toggle HTML element, swing component. Then we have a component in the web page, in the web client, recorded on the web client, not the swing client, and then back again to swing. So this kind of interaction works very neatly, and you can have the same set of tests for your desktop application running on a Windows desktop or a Linux desktop, whatever, and the application running in Webswing with just a few switches and a bit of option tuning, and running the same. So I just saw was a chat message coming in. Actually, we have two so far. I'm sorry, I can't react immediately because I barely see them when doing the presentation. The first question was whether you need to add anything to the original Swing application for QF-Test to work. The answer to that is no. You just start your application from QF-Test. QF-Test will dynamically attach an agent and do everything dynamically. Yeah, it should run completely out of the box. And you're welcome to give it a try it out, get our evaluation version, or hook up with us for doing a demo session on your application. And second question, have you thought about an alternative way to test by checking the component hierarchy in the browser? Relying on Webswing Selenium. Yeah, well, there is no component hierarchy in the browser. There is just the canvas. There is no hierarchy. That's what I tried to show before. The canvas doesn't have any subcomponents. Yeah. So in that case, even if you do geometry mapping from the Swing application, you would never get to the same level of testing that we can do with the Swing engine, because there are so many other things to consider. Yeah, for example, timing. Yeah, when you see how fast these tests are running. Or this one here. Yeah, so you have to make sure that you're going as fast as you can. We always get demands for our tests need to be faster, faster, faster. Yeah. While on the other hand, you must not go too fast. Yeah, you must always make sure that the Swing application is ready to receive the next event, that things go in sequence, and also the checks we're doing. Yeah, besides the text checks, for example, let me take a JTabbed pane here. We have many different kinds of checks that are all relying on the internal states of the complex components. Yeah, which is the selected tab, which text tabs are here. When we look at trees, QF-Test can automatically expand trees nodes. Yeah, things like that. The scrolling visible. These are all things that you could never do just using the web interface. So I hope that question is answered. If not, feel free to elaborate. Another question coming in by chat. For the remote connection to the Webswing server, yeah, let's get in touch and let's try to set this up on your system. As I said, it's really tricky. Let's set aside a bit of time. I've done a proof of concept on a Linux system with a Webswing server. It requires customizing of the Webswing configuration. and installing QF-Test on the target system, or at least copying a version of QF-Test there, but we can try to get it running for you. Yep. Okay. Any further questions now while the recording is still running? Any more questions? Otherwise, I'll say thank you very much for attending. Questions have been very interesting. Big thanks to Igor and Andre for joining. They had to go through 2 sessions of me just going on and on and on.
Thank you very much. It was really good.
And yeah, it's a lot of fun working together with Webswing. And as I said in the German version, guys are great, and QFS has a very good reputation for our support and being very quick and very to the point. And from all my experiences, I can say the same for Webswing. Been extremely helpful whenever we needed help, and I'm sure that by working together with you as customers, any problems should be possible to get resolved.
Yeah, I agree.
Thank you.
Okay. Thank you, everybody. Have a great day.